right, so let's do another example problem here. Let's say that I've got two metal plates, okay, and one of them is going to be positive here, and one of them is going to be negative. So that means there's going to be an electric field pointing upwards in there. And I have a proton. Let's say the metal plates here are 3.5 centimeters across. And I have a proton that I am shooting between these metal plates, and it has an initial velocity. So the initial velocity of the proton is 4.25 times 10 to the 5th meters per second. So what's going to happen? Well, when the proton is between these plates, it's going to experience a force that is upwards. Okay, so that means it's going to deflect it. And so I want to know at what angle is it deflected. Okay, so why do we even care about deflecting a proton? Well, this is actually something that is used in certain types of cancer therapy. And that is that it's called proton therapy. And what you do is you send protons in, and you want to first of all send them with a certain energy that makes it go a certain depth into the body. So you would do something similar to our previous example to get the protons going at a certain speed. Okay, that gives them a certain kinetic energy. And then the problem is the protons are just going down a tube. You want to actually shoot it into the tumor, so you need to direct it. And so the way you move the protons is you apply an electric field as they're going past, and this deflects it and targets a particular spot. And so this is basically the sort of things that you would do in proton therapy treatment for cancer. This is also used in molecular etching. You can actually use either protons or sometimes electrons. It's called electron beam epitaxy, in which you can take a semiconductor and shoot things into it to actually etch microscopic channels into the surface of a semiconductor. Basically, you can build an electronic chip, in microscopic scale form. And so these are the sort of things that this type of technology is used for. Okay, so I need to know, from what I've just given you, I want to know theta. Okay, so how do we find theta? Okay, well, it's initially going this way. So the initial velocity is in one direction only. It is initially 4.25 times 10 to the 5th meters per second I. Okay. Now, after it's been through my device, it now is going this way. So that means it's got a Vx component and it's got a Vy component. So if I want to find theta, that's going to be the inverse tangent of Vy over Vx. So in order to find the theta, I now am going to need to know the Vy and the Vx. Okay, so what we've got here is basically a two-dimensional problem. Okay, so before it enters the space between the plates, there's no force acting on it, and so it's just going in one direction. After it leaves the plates, there's no force acting on it, and so it's going in one direction. So it's between is where it's changing, because there's a force on it. The force makes an acceleration. So we have an acceleration. The acceleration, if the electric field is only up, the acceleration is only up. And so the acceleration is only in the y direction. So you recognize this problem as a Chapter 4 problem at this point. So Chapter 4 of your textbook, okay, that's where all this comes in. Okay, and so Chapter 4, it's two-dimensional motion. So x equals x naught plus vx naught t plus 1/2 ax t squared. We know that y equals y naught plus vy naught t plus 1/2 ay t squared. Okay, we know that v x equals Vx naught plus Ax times time. We know that Vy equals Vy naught plus Ay times time. Okay, so there was no initial y component, so those terms are zero. We can put our origin where we started, so the x naught and y naught are zero. There is no x acceleration. Okay, and so that makes it really simple. X is just Vx naught times time. And the final Vx is equal to the Vx naught. So the final Vx does not change. It stays the same that we started with. Okay, so Vy is what we're after. And so Vy is just going to be Ay times time. Well, time we can get as x over Vx naught. Okay, so that the distance we traveled, we said was 3.5 centimeters, so that's 0.035 meters divided by the velocity, which was 4.25 times 10 to the 6 meters per second. And so the time comes out to be 8.24 times 10 to the minus 8 seconds. Okay, so that's how long it took to go through there. So Vy is just going to be Ay times time. We've got time. All we have to do is find the y acceleration. Well, we know that F equals ma. We know that the F is going to be q times e, and so that's equal to ma. Okay. And so the A is just going to be equal to QE over M. Okay. And so the Q is fundamental charge because it's a proton. Okay. And I told you that E was 7150 newtons per coulomb. So that's the electric field that's in there. Okay. And so this is going to be 1.602 times 10 to the minus 19 coulombs times 7150 newtons per coulomb divided by mass of a proton. Mass of proton is 1.67 times 10 to the minus 27 kilograms. So A, this is our AY, that turns out to be 6.86 times 10 to the 11 meter per second squared. Okay, so now we're ready to put all the stuff together. So that would tell us now that Vy, which is Ay times time, is going to be the 6.86 times 10 to the 11 meter per second squared times the time, which we already figured was 8.24 times 10 to the minus 8 seconds. So Vy is going to be 5.65 times 10 to the 4th meters per second. Okay, so to find the angle that it is going, I got Vx, I got Vy. Vy was 5.65 times 10 to the 4th meters per second there. Okay, Vx never changed. That was 4.25 times 10 to the 5th meters per second. So the angle is going to be the inverse tangent of the Vy, 5.65 times 10 to the 4th meters per second, divided by 4.25 times 10 to the 5th meters per second. So the angle is a deflection of 7.57 degrees. Now, that was what I asked for. But I could also ask, what's the final velocity? Because we've now changed something, so did that change the final velocity? Because, you know, again, with proton therapy or electron epitaxy or even proton epitaxy or something, it makes a big difference what the actual energy of the particles is. So have we changed the kinetic energy any? Well, to find V, that's going to be the square root of Vx squared plus Vy squared. Okay, we've got those numbers there. You plug them in. That's 4.29 times 10 to the 5th meters per second. So it actually is slightly faster, so there is slightly more kinetic energy in there. Now, again, this would have to be taken into account in how you did this to set it up to begin with. So so you would have to adjust everything up front to account for this. But this would be an example here of a little bit more complicated problem, still using just a point charge in an electric field and how it behaves.